All right, here we are again, going over the exam, exam number 2. This is one version of the exam. This is question 1. If you have the other version of the exam, it's question number 5. Which of the following regarding colligative properties of a solution is not correct? And so the key word here we're looking for is not. All right, and so vapor pressure reduction is a colligative property. That is indefinitely a colligative property. That's what both freezing point depression and boiling point elevation are based on, is the change, or the reduction rather, in vapor pressure. Letter D, the change in boiling point is due to the presence of the solute is a colligative property. That is also true. That is the definition, again, of a colligative property. It depends on the solute in the solution. C, colligative properties depend on concentration of particles dissolved in the solvent. Again, that's exactly what colligative properties are. It depends on the solute dissolved in the solvent, and sometimes that solute breaks into more than one particle, and so really it's all about the number of particles, and we use the Van 't Hoff factor to figure that out. B, the temperature range over which a solution remains liquid is larger than that of a pure solvent due to the presence of the solute particles. Yes. Again, B is also true there because it expands the region. Both the boiling point goes up and the freezing point goes down, and so the temperature range over which that solution remains liquid is larger. And that leaves only one answer remaining, and it says the freezing point of a solution increases as the concentration of solute increases. Well, the word is, or the term is, freezing point depression. And so freezing point depression means down. And so down and increases are opposites. And so the answer to this one is A. All right, number 2, 0K, the entropy of a perfect crystal is, at 0 Kelvin, everything stops vibrating. And if everything stops vibrating, you don't have any translational, rotational, or most importantly, vibrational motion. And if you have no motion, you have no entropy. And so the answer to this one is D. That's a simple definition problem. Next up is question number 3, which is also question number 9 on the other version of the exam. It's asking about a relative rate of reaction. And so we have this reaction where 2HI as a gas goes to hydrogen gas and iodine gas. And so it says if the concentration of I changes at a rate of negative 0.45, so this right here has a rate of negative 0.45, what's the rate of appearance of I2? And it turns out that since the coefficients of H2 and I2 are the same, it's going to be the appearance of both of those. So it could have said H2 or I2 here. Okay? It has to be an opposite sign, okay, because it's appearing rather than disappearing. Reactants disappear, products appear. And since the coefficient here is a 2 and the implied coefficient there is a 1, it has to be half as much. And so half of 45 is, or half of 0.45 is 0.23. This was never going to be an answer. This was never going to be an answer. It could have been the same if the coefficients were the same. We're talking about the relative rates. And it could have been 2 if it was a 4, but since that one was the 2, it has to be, every time you go across the arrow, 2 of those go away, but only one of those products shows up. And so we have that. Keeping going, number 4. Number 4 on this exam is also number 8 on the other exam. Which of the following statements regarding the determination of reaction rates is true? So we're trying to find how to get the rates. And so the answer here is looking for which one is true, unlike the previous problem where it was looking for, number 2, where it was looking for not correct. We're saying which one of these is correct. And if nothing else, D there is something that I've said over and over again. You can't just look at the stoichiometry of a reaction to pick reaction rate. So it doesn't matter what the reaction looks like. How that happens is going to be very different. And then E is something we also talked about in class, how over the course of a reaction there's less reactants around. And so the reaction is going to slow down. So the average rate of reaction slows down as time progresses. C is also a rewording of the same thing that I just said for E. the reaction rate determined at one instant is the same at any other instant. And that can't be true if it slows down as we go. And so we're left with A and B. And experimentally determine reaction rates. And so that's exciting, right? So you see experimentally determined because I said that in class. Okay? And so you think that's the right thing, but there's one more part of the rate law there that's important. So you have the concentrations of A and B or whatever is there, but the important part here that we're talking about for part A is this K. And remember the K has to do with orientation and collisions and activation energy and a bunch of other things. So there is one term that's different than just concentration. And so the answer here is B. B, it says reaction rates can be measured by monitoring how much product is generated or how much reactant is consumed. And so that is the definition of rate, right? Is concentration, the change in concentration over the change in time. That is the definition of rate. So 4 is B. And then on to number 5. Number 5 is also number 2 on the other version of the exam. This is the same question I asked on the first exam. Which of the following statements regarding spontaneous processes is not true? And so we're asking for which one is not true. Particles tend to be more spread out during spontaneous change. One of the definitions of spontaneous change is that the delta S of the universe increases. And so if it's going to be spontaneous, then the particles need to be more spread out. B, spontaneous reactions are not always rapid. My car has been spontaneously rusting for the last 15 years. It's a very slow process, thankfully, so I don't need to buy a car every new year. But it is a slow, spontaneous process. C, the definition of spontaneous process is one that proceeds without outside intervention. And so that is true also. D is the correct answer. Spontaneous processes are exothermic because ice pack. Just because you're spontaneous doesn't mean you're releasing heat. You can also consume heat, and that has to do with the delta H versus the delta S, so that the overall delta G is negative for spontaneous process. The last one, E, the motional freedom of particles tends to increase during spontaneous change. That is a rewording of A. More spread out, more motional. So they either get faster or they get farther apart. More translational, rotational, vibrational motion. And so we have the first 5. Here we have question number 6. Question number 6 is again talking about relative rates. And so we have a reaction here that has a number of coefficients for its reactants and products. And so the rate of reaction in terms of the change in concentration of A versus time would have to be related to A, and so we want the concentration of A, and we want to use that coefficient. And so using that coefficient removes B, C, and D. And so it comes down to either A or E. In order to normalize all of these rates to the same rate, we divide by the coefficient. And so we have the negative sign correct because it is indeed losing because it's a reactant. And so when we divide by the coefficient, we divide by 2, which is the same as 1/2. Next, question number 7 is also question number 13 on the other exam. Which statement regarding osmotic pressure is not correct? Osmotic pressure, and the equation for osmotic pressure is I mRT, and that's M molarity in this case. And so A depends on the value of the gas constant, check. Increases with increasing temperature, that's the T, check. Increases with increasing molar concentration of solute, that is capital M there. Is the same for solutions with the same mass percent of solute, is greater for those two. So that's a question about the Van't Hoff factor, and sodium sulfate will have 3 particles versus 2 particles for sodium chloride, and so that gets rid of E, thus leaves D. Mass percent, it's not mass percent, it's concentration. In terms of molarity, it's moles per liter, not grams per 100 grams. Number 8, we're asking about spontaneous processes again, so we want something where the entropy increases for the universe or the delta G is less than 0. In number 8, this is also number 11 on the other version of the exam. In a spontaneous process, which of the following always increases? And it always increases with the entropy of the universe. Again, just a simple definition. Number 9, in the other version of the exam was number 6. What modes of motion does a gaseous molecule of chlorine have? Motion is only 3 kinds of motion, and that's translational, rotational, vibrational. All the other ones talk about states and all that stuff, and energy. That's not motion. And so the 3 kinds of motion are translational, rotational, and vibrational. Number 10. Number 10 is number 12 on the other version of the exam. Indicate which aqueous solution has the highest vapor pressure. So remember, colligative properties are all about vapor pressure reduction. And so the highest vapor pressure would have the least amount of solute. High vapor pressure means low solute concentration. So which of those has the smallest concentration? Well, it brings it down to C and E. And you can look at C and E and notice that one of them is a 1-to-1 salt, potassium chloride, and the other one is a 1-to-2 salt, magnesium chloride. And so the one that has the smallest I will have the least amount of solute, and so that answer is C. Number 11. Number 11 is number 3 on the other version of the exam. Which of the following processes is predicted to decrease the entropy of a system? And so we're talking about decreasing entropy. And so pressure increases. Well, I'm not sure, so let's get back to that one. B, the number of particles increases. Nope, that's going to increase. Temperature increases. Nope. Volume increases. No, it gives it more room to spread out. You have a bigger room, it's harder to clean it. And so that leaves us with A and E. And so if A is true, then E has to be true. If A is false, then that is the correct answer, because we're looking for it decreasing the entropy. And so when pressure increases, we take something that was in a small amount of space and make that space even smaller. And so anything that was distributed here is now over a much smaller version. And so the pressure has increased, and that is going to decrease the entropy. So it is indeed A, and not all of the above. Number 12 is also number 7 on the other version of the exam. This is very similar to question 10 here. Which of these will have the lowest freezing point? So in this one, we're looking for the one with the most solute particles, keeping into account the Van't Hoff factor I. And so we have 0.1 for potassium chloride, 0.08, 0.1, 0.04, 0.05. And so if we just look at A and E, we can see that A wins because it's a 1-to-1 salt. If we look at D and B, they're both 3 particles. I is 3 for both B and D. And so B must win that one. And so now we're down to here. In A and C, we have both 1-to-1 salts. Potassium chloride breaks apart into 2 species, 2 parts, 2 ions. C, magnesium sulfate, also breaks down into 2 ions, magnesium and sulfate. And so those are equivalent. There can't be 2 answers, so that should make your hair stick back on the back of your neck for a second. Some people might think that because there's a double charge on magnesium, that makes it stronger. We can debate that some other time, but the real answer for this question is B, because magnesium chloride has an I of 3, and 0.08 times 3 is going to be 0.24, whereas 0.1 times 2 for both of these is only going to be 0.2. And so the answer there is B. Moving on to page 3, we're at number 13, which is also number 15 in the other version. The following graph shows the kinetics curve for the reaction of oxygen with hydrogen to form water. And so it has that reaction of oxygen and hydrogen forming water. Which curve is hydrogen? So in this reaction, hydrogen is a reactant. That means it's going down. And so we have two choices there. So it can't be the dashed curve, and it can't be any of those. Neither of those works. So the answer is, well, it can be either one for A, it can be just the gray one or just the black one. And so again, here we're looking at relative rates. There's an implied 1 at the beginning of this reaction. There's a 2 here in front of the hydrogen. And so the removal of hydrogen is going to be twice as fast as that of oxygen. And so when you compare the two, oxygen is going to decrease more slowly than hydrogen. Hydrogen is going to decrease more quickly than the oxygen. And so the one that decreases the most is C. And so the answer to 13 is C. Number 14 is also number 10 in the other version of the exam. Let me move it up here. Processes that are always spontaneous when blank and blank. And so we're looking for the case where when we solve for delta G, we always get a negative number. And so the case where we always get a negative number, delta H has to be negative. And so that's less than 0. And so none of these true can't be true. And so the choices are when delta S is positive or delta S is negative. And so because of this negative sign that's already there, the delta S needs to be positive, the increase in entropy of the system. And so the answer is B there. Number 15, in a rate law, in the order with respect to each reactant is determined by. So now we're finally talking about order, and so we're talking about the exponents that we're determining here. Okay? The only way to determine those exponents is by experiment, and so that's D. Okay? It has nothing to do with concentrations. Okay? It's determined by experiment. You have to. It's not just one concentration, so it's not A. It's not. We're not looking at forward and reverse. I haven't really talked about that yet in class. Again, it's not reactant concentration. So A and C, it's not just the concentrations. And E, the stoichiometric coefficients don't matter when we're determining order, only when we're looking at relative rate. And the last one is number 16. That's number 14 on the other exam. Which of the solutions here will have the highest vapor pressure? This is asking the same question as a previous slide. So it's essentially saying which one has the least amount of solute, and the one with the least amount of solute is A. Just some quick notes about the problems. This is the boiling point elevation problem. And so it talks about an aqueous, and I bolded this word on purpose, sucrose solution is found to be 100.49 degrees Celsius. A normal or empty water, aqueous, will boil at 100 degrees. And so many of you went to the sheet and grabbed this equation and used it. However, the part that most of you or many of you missed is that it is delta T. And so delta T means the change in boiling point. So you don't just stick 100.49 in there, you stick 0.49, because that's how much it changed from normal. Moving forward, sucrose has a 1. This is 0.512 for the Kb. And so we can solve for the molality of that solution. Solving for the molality of that solution gives us moles of solute over kilograms of solvent. There was also a number of issues where grams went to kilograms and people all of a sudden had 500,000 kilograms. Grams are smaller than kilograms. 1,000 grams is 1 kilogram. And so in terms of kilograms, it's 0.5 kilograms. And so when you solve for this equation, you get the number of moles in 1 kilogram. We don't have a whole kilogram of solvent. We only have half a kilogram of solvent. And so then we need to change from 1 kilogram to a smaller number of moles for our solution, which is different. In terms of the sodium chloride part of this question, essentially what happens when you change I is equal to 2. and that was what I gave most of the credit for, whether you actually calculated the right answer or not. Because of that, you'd also need the different molar mass of sodium chloride, and that's something that there was problems I did in class. There was problems in the homework for this, of this almost exact nature. This problem with the carbon monoxide and hydrogen gas, that's really just a plug and chug problem using this equation. Okay, the biggest part of issue here was that delta H is in kilojoules per mole, delta S is in joules per mole Kelvin. You need to change the temperature to Kelvin. It can't be Celsius. And also, after you do that, you're going to multiply by Kelvin. And so the units here cancel 1 and 2. 1 and 2. And so you have joules per mole minus, or excuse me, kilojoules per mole minus joules per mole. And many people did not deal with this kilojoules. And so it all goes back to chapter 1 and changing units and the metric system. All right, the next problem was determining the rate law for the reaction. And the rate law is rate is equal to K, and then we're going to take a look at all the reactants in the problem and raise them to some coefficient. And if you understood what a rate law was and wrote that, I gave you credit, regardless of what you did. And so in order to look at how to determine A, B, and C, the exponents here, we need to find reactions where only one concentration changed. And so if we look between experiments 1 and 2, only the concentration of bromate, BrO3- changed. And it doubled. The concentration doubled, and also the rate doubled. And so since there's a doubling of the rate with a doubling of the concentration, A is equal to 1. The next set that we need to compare is equations 2 and 3. In equations 2 and 3, we see that the concentration of bromine goes up by half, so by 50%. And what happens to the rate there? It goes up by 50%. So once again, the coefficient, the exponent for B is going to be 1 for the bromine or bromide ion. The last one we need to look at is we need a set of equations where only the hydrogen ion changes, and in that one we're looking at equation 4 versus equation 1, and the only thing that's changed is the hydrogen ion concentration, and that's increased by 2.5 times. And so we can get an equation where 0.25 over 0.2 over 0.1 is equal to 5 times 10 to the minus 3 over 8 times 10 to the minus 4. And we get 2.5 is equal to, or 2.5 to the x is equal to 6.25. And so the only thing x can be there, or more appropriately C can be there, is a 2. And so the rate law is rate is equal to K, bromate to the first power, bromide to the first power, and hydrogen ion to the second power, which doesn't look like any of the coefficients there. Well, one of them, but it does not deal with that. Now the second part, part B, you did not need to get an answer for part A to get full points for. Take whatever you used in part A. If you didn't know what a rate law was, then yes, you are not going to get any points for part B or probably part C. But that seems to be a bigger issue to me. So you take whatever you have for your rate law that you determined in A, and it says determine the value of the rate constant. The rate constant, remember, is K. And so now we just take values from one of the experiments. And so if we take the values from experiment number 4, plug in 0.1 to the first power, 0.1 to the first power, and 0.25 to the second power, and then we have the rate is 5 times 10 to the minus 3. We can rearrange that into rate divided by concentration of bromate, concentration of bromide, and concentration of H plus squared. That will equal K. In this case, we have 4 molarities there. We want our rate to be molar per second, and so we need to get rid of them, and so this is going to be m to the third seconds are the units for this K. If you were consistent, if you determined something else for your rate law, but you were consistent with the units that you achieved in part A, I gave you full credit for this problem. Okay, so it was not a case of if you got A wrong, you were going to get B wrong. In fact, most of the points people got were actually on B and C and not on A. Part C then is say, okay, now that you have K and you have a rate law, you can just put in any value for any of those parts and get a new rate. So now that we have an answer here, we can get the rate. And so this number goes into there. This number was 8, by the way. And so you plug in the 8 there, and then change the concentrations for bromate, bromide, and H+. If you're looking at to what the answer might be, it's going to be somewhere in between, somewhere bigger than experiment 1. So the answer has to be bigger than experiment 1 because all those values were 0.1. And so since all those concentrations went up, it's going to get faster. For this last problem, calculate the standard entropy change. And so in this problem, it was a matter of doing the number of moles times the delta S of the products minus the moles of the delta S of the reactants. Many, 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 many of you chose those to be products and those to be reactants. That is incorrect. Just flipped it up. The products go first. Again, it's always final minus initial. And so those don't belong there. They belong on the other side. And the same is true for the other ones. And so we just multiply the coefficients times the S's in the table. And you get out an answer. The answer that you get out is indeed negative for this problem. And so I asked part B, does the sign of your answer make sense given the equation? And again, if you did the math wrong and got a positive number and answered that question based on your answer correctly, I gave you the points. Okay, it was only 2 points, but I gave you the points. And so as long as you answered B as long as you answered B consistently with how your answer for A came up, you got the points for part B. And so we have a negative number here, and it's asking, does the sign make sense? And so we're looking at the equation. 6 things go to 7 things. 6 things go to 7 things should be a positive entropy. We're getting a negative entropy. Why would that not be true? And so many of you answered, no, that doesn't make sense because you're going from 6 things to 7 things. And I gave you credit for that. The real answer why that answer is negative is because of this change as a liquid. And so we're going from 6 particles that are gaseous to 3 particles that are gaseous and 4 particles that are liquid, which is a lot less entropy. So the negative sign makes sense because it goes from a gas to a liquid. I hope this helped. Thank you for listening all the way through. Please come see me if you have any issues with any of the answers to these problems.